So in the previous lesson, we spoke about these things called inequalities. And these inequalities were a lot like equations, except instead of finding one solution, we had to have a whole bunch of solutions. So, if we solved something simple like, if we had 2x is, let's say we had to solve this inequality for x. An example of what we did in the previous lesson is we would divide both sides by 2 in this situation. And if we did that, we would then have x greater than a half. And what's different about inequalities is instead of there being one solution for x, there can be many solutions for x. So what's a number greater than a half? One of the solutions to this inequality could be that x could be 3/4. And another solution could be x could be 2. And you can imagine how this gets really tiring listing all the solutions. So what we do instead of that is we put our solution on a number line. And we use what's called the critical value. And the critical value in this case is a half. And our solution, or my solution to this inequality, will be all numbers greater than a half. And what we learned in the lesson was that if we want it to be strictly greater than a half, we need to have an open circle. And then we have an arrow showing all the numbers that are possible solutions to this inequality. And so that's really a summary of the last lesson. Can I have a quick little thumbs up, thumbs down vote if that is sounding familiar to you? Obviously, if you're new here, it'll look a bit different, but I just want to get a quick little feel for the group as to how we're doing. And this is called a linear inequality because the inequality only has a variable with a power of 1. Okay. Cool. Well, I'm going to take Vivian's question in a moment, or maybe that was just a little vote of confidence. I want you to try and solve this inequality using what you know from the previous lesson. It's a quick little multiple choice question, and I want you to try and solve this. And then when you think you've got your answer, I want you to put the answer that you think is correct in the chat. So A, B, C, or D. So over to you guys. Let's see what you've remembered from the last lesson. And for our new students, if you want to put a tip for them in the chat, put a little tip for them saying, this is how you would start, because maybe they'll feel a little bit like, how do I get going with this? So if you feel like you've got some knowledge you're willing to share. No problem, Vivian, that's fine. It also happens fairly often. Also, I like talking to the students, so you can even come on here and just have a chat anyway. I like it. It's a nice mixture of answers, which means there's learning to be had. My tip for you is to treat it a bit like an equation. And if you had an equation, you'd want to get this 4x to the other side, and you'd want to get this plus 1 to the other side. So see if that can help you. And then lock your answer in when you feel like you've got it. Then what have we got here? Divide both sides by 2. I lie. It should be divided by 2, so x is less than -4, which is going to be answer A. And normally, in this case, we just had to identify it, but sometimes we would draw it on the number line, but that's good. Okay, that looks good to me. I think I saw, if there are any questions, please feel free to raise your hand. But from what I could see, that was looking pretty good. Let's do one more like that, and then we're ready to move on to what's called quadratic inequalities. Oh, sorry. Can you solve this multiple choice inequality question? Off you go. There's actually two ways you could do this one. And if there's any questions, feel free to raise your hand. We can have a little chat about what's going on. I know for our new students, you might be thinking a little bit, But if you go back and watch the video from Monday, I promise it will make a lot of sense. Now what should I do with this one? Tell me in the chat, what do you think I should do first? Because I see in that there's quite a few C's, quite a few D's, and then there's a couple of A's. So there's a nice bit of mixture of opinions. So one, you could take, okay, so let's actually do both these methods and I'll show you that they work. The one method is to take the 5 to the other side. The other method that I can think of would be to take the minus 2x to the other side. And both those methods can work, but you just have to be careful about what you do. So I'll call it the yellow method and the blue method. So if you did the yellow method, let's say, if I brought the 5 across, I would get 7 minus 5. I get minus 2x less than 2. Okay. And now I have to divide by -2 on both sides. Now, in the previous lesson, there was something special we had to remember if we divided by a negative. What was that? Who can remember what that was? So I know what this is going to be. That's going to be x. This is going to be -1. Yeah, the inequality symbol, which is now with the big mouth going towards the right, the big mouth needs to go to the left. So that would be the one way of doing it. The other way of doing it is if I bring the 7 to this side and I bring the 2x to the other side, then I would get that. Then I would get -2 is less than 2x. I would divide both sides by 2. And I would get -1 and I get x, which is the same answer because the big mouth is pointing towards the x. And so the good news is no matter what method you do, you should get that answer. And which option is that? X, the answer should be D. Okay. Quick little vote, thumbs up if you followed the first 2 questions, thumbs down if you're feeling a bit unsure. Just want to do a quick little check-in. Okay, fantastic. Yeah, a couple of uncertain ones, but we're there. All right, so now the second part of today's lesson is going to move from what we call linear inequalities to a quadratic inequality. Now, that sounds like a bit of a fancy word. Why would this be? I mean, in some ways, this is factorized already, so it's a bit hidden away. So let me actually multiply this thing out for you. So you don't have to multiply it out. In some ways, I want you to keep it like this. But just to show you what I mean, okay, so I took this inequality on the left-hand side and I multiplied it out, and the same inequality of it is the one that you see there is factorized. If it hadn't been factorized, if it was written out in its normal form, can you see that there is a power of 2 in the house? So this x squared is different to what we had before. That is what makes this a quadratic inequality. So there's an inequality because of the inequality sign here, but there's an x to the power of 2. Now, what's happened is you have factorized this. So in order to do a quadratic inequality, one of the things you're going to need to be able to do is to factorize. And so this is a trinomial, and there's different ways of factorizing the trinomial, but you get this trinomial. Give me a thumbs up if you understand how I would go from here to this step over here. I went the other way around, but I just want to make sure you understand how the two are connected. Okay, now. Fantastic. So how do we solve a quadratic inequality then? What are the steps that we need to do? There's two ways of doing it. I'm going to show you the first way and then the second way after that. We need to find values of x that when we multiply these two brackets together, it ends up being less than 0. So just to show you how this works, sort of, let's just choose a number like 5. If I put a number 5 in there, 5 plus 3 times 5 minus 1, is that going to end up being positive or is it going to end up being negative? Tell me in the chat, would this expression be positive or would it be negative? So this would be 8 and this would be 4. So is that going to end up being positive or negative? Okay, so it's going to end up being positive. Now, I was just subbing in values there to show you, but what I want to zoom out for a second to do is to say, look, I'm looking for values of x that when you multiply this together, it's less than 0 or it's equal to 0. And I just found that if I put a 5 in there, I end up with a positive. So 5 can't be a solution. Now, it would be very complicated if I went and tried every number like that. So we need a better method. And the method we're going to do is like before, we're going to draw a number line. And on the number line, we're going to put the critical values. Sometimes they're called the 0 values. And I want to know from the class, what do you think the critical values are for this particular quadratic inequality? Which values would make the expression equal to 0? What do you think the critical values are? I'm kind of just throwing this out there, but I kind of feel like if you look at this, another way of saying it is, if this was an equation, what would the answers be? Aha, Mbali and Zanele, Boma, I agree with you all. The critical values are going to be -3 and 1. Can anybody come online and explain to me how you got those values? Because I see the 3 and -1. Anybody willing to explain how they got their -3 and 1? Anybody have any ideas? Okay, so it's a little bit like you use the opposite of what's there. What value would make this 0? -3 would. What value would make up? Let's go to Sibabale. Can we unmute Sibabale?
Afternoon, sir.
Hey, can you talk me through how you got from this to this?
Sir, can't we actually equal the inequality to 0? Can't we change the inequality to an equal sign?
Yes.
And then we can say x is equal to -3 or x is equal to 1.
It feels,
and then we change.
Yeah.
And then we change the equal signs to inequality sign, to the inequality sign.
Yeah. So I think the main thing that I noticed, and I don't know if you noticed this too, is it feels a bit like when we solve quadratic equations. You know, when you have to get the 2 steps, like that feels like the one answer, and this feels like the other answers. Yeah. Awesome. So now here's the next step. We're going to choose a value bigger than 1. So we've got these critical values, and we choose a value bigger than 1. So I always choose, let me choose 10 because it's very easy. If I choose 10, And if I choose 10 and I put 10 here, we know that 10 plus 3 will end up being positive. So I'm just going to write positive. 10 minus 1 will also be positive. And so positive times a positive, I'm going to put a positive value here. This is called a sign table. Now, what this is telling us is if I choose a number bigger than 1, it's going to be this expression will have a positive value. If I choose the number 1, the value will be 0. And every time you go over a point, the value of this expression will be negative here. And the values of this expression when you are below -3 will be positive. So now, in order to answer this inequality, I'm looking for the region where this expression is negative. Looking at my sign table, what values of x do I need to have have an expression which is negative or equal to 0? Who would be willing to take a go at this? If I had to draw in what region of my number line will be the answer, given that I'm looking for when it's negative or equal to 0. Any ideas? So it's positive if it's greater than 1. It's negative between -3 and 1. And it's positive when x is less than -3. Aha. Okay, let me show you. I can see there's a little bit of confusion. So the answer that I'm looking for is going to be when x is between -3 and 1, including -3 and 1. So the way we would write this is we go x is greater than or equal to -3 and less than or equal to 1. And I'm going to back up a little bit just to make sure I've got you all on board. If you choose a number like -4, for example, so let's say -4. -4 is somewhere down in this part of the land. What the sign table predicts is that if I put -4 into this expression, I should end up with a positive value. So let's see. -4 plus 3 is here, and -4 minus 1 is here. If I had to rewrite that, I'd get -1 times -5, which is +5. And +5 is positive here. So that is not, I want the values of x which are less than or equal to 0. And so I'm really looking, my answer is sitting between -3 and 1. And that's why I write it like this. Now I can see for a lot of you, I think I need to do another example for you just to make sure you're following me. And so I'm just going to give you a second to take a screenshot. I'll do another example for you to follow this process. Okay. So take a screenshot now if you need to before I do a second example. Okay, so let me look at a second example. My second inequality says solve for x if x squared is less than 25. Now, when we solve a quadratic inequality, the steps that we normally follow is we would normally move everything to one side, kind of like we were solving an equation. So to move everything to one side, I'm going to go x squared minus 25 is less than 0. Then the second step is going to be to factorize. What method of factorization might I be able to use for x squared minus 25? Sakile, yes. Who agrees with Sakile? Boma does too. This is a difference of two squares. So difference of squares. So if I was to factorize this, I would get x minus 5, x plus 5 is less than 0. Okay, now, my third step is to find critical values or the zero values for this expression. So what are my critical values for this particular algebraic expression? So that was the original bit, and then we factorized it. What are my critical values? Take a moment to think about that and pop your answer in the chat. So I think it will be 5 or minus 5. Okay, then step 4 is put on number line and make a sign table. Or in the other method, you would just draw a little parabola. Some teachers draw a parabola, which I'll do for you now, but put on number line and make a sign table. So let's do this step. So I'm going to draw my number line. So draw my number line. And my two critical values are minus 5 and 5. Because I'm going to show you the other method, which some teachers may have used in class with you, I'm going to draw a second number line just to illustrate. Okay. So in the method that I showed for the previous example, I look at my biggest critical value, which is 5, and I choose a value bigger than 5. Something bigger than 5, I'm just going to choose 10 because 10 is easy. And now I ask myself, I'm thinking about this region. And I say that when I put a 10 in here, 10 squared is 100, 100 minus 25, that's going to be positive. And this is where I want to make sure I've got you. I'm actually going to take a little vote. Thumbs up if you understand how I'm figuring out that this region is positive, because I'm subbing in a value like 10, which is just over here, and it tells me that this expression must be positive. Okay, so I think that's where I'm losing a lot of you. So I'm going to slow down a little bit. So basically what I'm doing is I'm saying, in fact, for those students who are feeling confused, give me a number bigger than 5. So choose a number. The only restraint is that it must be bigger than 5. Put it in the chat for me now. Okay, so Sirvale, Annie. So Annie said 8, so I'm going to take 8. If I put 8 into this expression, 8 minus 5 is going to give you a positive number, right? So 8 minus 5 is going to give me a positive. 8 plus 5 is also going to give me a positive. And what is a positive times a positive? It's positive. So I put a positive here. Now, what I'm going to do is as I go over this critical value, it goes from a positive to the opposite, which is going to be a negative. Then when I go over the negative 5, it changes back to a positive value. And what this is doing is it's summarizing the value of this expression. So if, for example, if I chose a number, give me a number between minus 5 and 5. In the audience, please give me a number between minus 5 and 5. Okay, I'm going to choose IV's 3. I predict, because I can see on my sign table that 3 falls in between here. If I put this into the expression, I should end up with a negative. Let's see. So if I put 3 in here, 3 minus 5 is negative 2, so it's a negative. And 3 plus 5 is a positive. What is a negative times a positive? It's equal to a negative. And good for me because that's what I predicted. Okay, now I need to read off my answer. So that's the last step. The last step is find answer. Now, I want you to predict in the chat, what do you think the answer is for this question? And I'm going to go to Tigger Batso. If we can unmute Tigger Batso now.
Good afternoon, sir.
Hey, how's it going?
I'm good. Sir,
What's
I
your
have a question. I wanted to ask that in between the critical values, is it always negative or it can change and be positive?
No, it can be different. So if I had started with the negative here, this would have been positive and that would have been negative.
Okay, sir.
Okay.
Okay.
So what do you think my answer is going to be? Because I want the area where the expression is less than naught. Can you see this is less than naught? So what do you think, what region do you think I'm going to get as my answer? I think because I need it to be less than naught, it has to be here, between here and here. So it doesn't include 5 and minus 5 because this thing is strictly less than naught. And so my answer would just be x is between minus 5 and 5. Okay, now this is a bit tougher than the linear ones. And when we come back after our break, we're going to practice these until the end of the lesson. But I just want to zoom out for a second and just make sure you've got the 5 steps. So you move everything to one side, you factorize using whatever method of factorization is appropriate, you find the critical values, you put on a number line and make a sign table. Now, some teachers would have done, instead of doing the sign table like that, they would have just done a parabola that looks like this. And that's because they're talking about this type of parabola. And when is this parabola below the x-axis? Well, it's below the x-axis between here and here. And so you can see my answer will be the yellow bit, which is x is between minus 5 and 5. And so that's also a common way of doing it. And it's not wrong to do it like that. Why is it an open bracket? Annie asked. Annie, the reason it's an open bracket here is that there is this less than sign. So we don't include, we strictly, it has to be negative. Whereas in the previous question, we had a less than or equal to. So that's why we had solid dots here and we had open dots here. Okay, so Ivy, it's not, we're going to do our next topic after this is functions. And when we do functions, I think this method will make a lot more sense. But for now, I'm going to stick with the sign table method unless there's overwhelming need for that one. Okay, awesome. Everyone, I've worked you hard. It's time to turn those cameras on and to stand up. We need a brain break because our brains need to click save as. And so let's stand on up. Ooh.
Please turn on your cameras, guys. Let's see your lovely faces.
Don't let me have all the fun. And then let's start by just rolling our shoulders. I can feel my neck is a bit tight. So let's just roll those shoulders. 1, 2, 3, 4, 5. Then roll them forward. 1, 2, 3, 4, 5. Shake it out. And then let's do a little twist. So slowly at first, and then turn from your hips. And as you feel yourself unwinding, you can just extend further. Oh, I'm almost turning around. There we go. No clicks today. All right, let us do a little shoulder stretch like this. Look out in front. 1, 2, 3, 4, 5. And then let's do the other side. 1, 2, 3, 4, 5. Then let's do some small circles. And then let's do some bigger circles. And we're going forward at this point. And then let's reverse the direction, but little circles. And then big circles. Okay. And then let's get our heart rates up. Let's do some jumping jacks. So make sure there's no one close to you, that you're not going to whack any furniture. And let's do at least 10, and then I'll decide how many more, depending on how we're feeling. Okay, 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. And there we go. Have a seat and see if you are feeling a bit more, if your heart rate has been right, sort of raised. That's the word I was looking for. And then let's see a quick little Maths 24 just to have a go at this. Maths 24, can you make 24 using these 4 numbers? And you have to use all 4. Can you, oh, I'm out of breath. Can you make 24 using these 4 numbers? I await your insightful answers. Oh, I'm awake now. I'm running the Two Oceans Half Marathon on the weekend, and I do hope that I have a little bit of residual
Oh,
fitness.
cool.
Because it's a lot longer than
That's so
10 jumping.
exciting.
It is kind of exciting in a carnival-like way. Yes, it is. There's like 10,000 people, so
Oh, wow.
it's good. I might be a bit tired on Monday though.
Yes. Understandably so.
Yes. All right, I'm waiting for our Maths 24 answers. How do we get to 24 using these numbers? So Sakila has said 5 plus 1 times 8 divided by 2. Now, where would your bracket be, Sakile? I think your bracket would have had to be here. Let me see if I agree. So 5 plus 1 is 6. 6 times 8 is 48. And 48 divided by 2 is 24. So that is correct. Otherwise, Tagavatso has said 5 minus 2 is 3. And that can be times 8 times 1, which also gives you 24. Or in Corsi, I think if you go 5 times, but you've used the 1, wait, 5 minus 2 times 8 times 1, 3 times 8. Yeah, no, that's right. Okay, so I think that's enough for one day, but there's 2 different ways already that you could use to get to 24. And yeah, that's just a fun little game that we play to kind of just zone out for a second and keep our multiplication and division and problem solving going. All right, let's go back to this thing called quadratic inequalities. I want you guys to have a crack at solving this quadratic inequality. So here is I will take questions as we go. And in fact, if you would like to ask a question about the previous one, or let me actually leave it up on the screen so you can see it. So maybe you can use that as like a helpful, so like that. So I want you to do this one, and I will leave the other one up as kind of a way to help you remember the process. So off we go. And while you do that, I'm going to grab some water. Okay, so I think step 1 is fine, but we need to factorize this. So it feels like if I was factorizing it, that's what I would be getting. And so now I need to find my critical values and put my critical values on the number line. And the critical values that I can see are -1 and 5. So I would put -1 and 5 on the number line. I'll give you some more time to. So this is -1 here, and this is 5. So now I choose a number bigger than 5. So let's say 10, because it's easy. And 10 minus 5 will be positive, and 10 plus 1 will be positive. And so when these two factors get multiplied together, they always give me a positive. So that describes this part here. Atule, let's come to you. I see you have a question. What would you like to ask about?
Good afternoon, sir.
Hey.
I would like to ask, where did you get the 1? Aren't we using the for the half of the number?
Okay, so let me show you where I got the 1 from, because I think it's a good question. Can you see my y minus 5 over here,
Yes.
and my y plus 1? Now, in order to get my critical values, I almost want to know when this bracket is equal to 0 or when this bracket is equal to 0. And y is equal to 5 is the critical value that would be, so like this one over here comes from this bracket over here. And then for this one over here, if I take away 1, I get -1. This critical value goes with that bracket there. So Atuli, does that make a bit of sense about how they're connected?
Yes.
And
Yes,
then,
sir.
no, I'm so happy I could help you. Thank you for your question. The thing that some students would get tricked by is they might not realize -1 is less than 5. So -1 must be to the left, and then there's 5. Let's go to Juliet. Juliet, what's your question?
Hi, sir.
Okay.
So my question is, see on the number line table,
Yes.
is the right side always positive and the middle negative and the left
Not
side
always.
always positive?
It's not always. It just happens that in the examples I've chosen, it's ended up being positive. But the reason it was positive, Juliet, is that I looked at the two factors. I chose a number, say, bigger than 5. I could have chosen 8. It doesn't, as long as it was to the right-hand side here. And I checked, if I put a number in here like 8, 8 minus 5 is positive, and 8 plus 1 is positive. And when you multiply these together, it gives you this positive here. But if one of the brackets had been negative, it would have affected this big positive over here.
Okay, sir. Thank you.
And Zanele has made a very good suggestion. Zanele said, isn't it easier to use the quadratic formula to get the critical values? Zanele, it absolutely is, depending on how good you are at factorizing. So if you're not great at factorizing, the quadratic formula is guaranteed to work. It just takes a bit longer. Whereas the factorizing is a bit quicker, but some people will find that hard. Choose whatever you think will be the best for you and just check that you're getting it right. Okay, let's finish this question off. If this was positive, when I go over a critical value, this changes to negative, and then this will change to a positive. So what did I want? Now I'm going to look and see that I wanted where it's greater than or equal to 0. So the region of my answer, it's going to be 0, and it's going to have a value of 0 here, and it's going to include the 5. So that's the one region I want the answer of. And then the other region I want an answer for is this part, because that's where the expression is positive. And how would I write this down? Well, I'd write it down that x is less than or equal to -1, or x is greater than or equal to, sorry, it's not x. I'm pulling variables out of nowhere here. The variable here is y. And it's important that you have the or. It's not and, because it could be either side and it can't be stuck together. It must be two separate answers, kind of like it's two separate regions on the number line. Okay, so it must be in two parts. Okay, now I think we need to squeeze in one more of these before today is over. So let me pull up the next one. I will leave the other one on the screen just so that you can ask me questions about it. But for those students who feel comfortable, go ahead and do this one. Solve the inequality y squared plus 8y minus 9 is greater than 0. And then I remain open for questions for those students who would like to clarify. No problem, Hearties. You can catch this last bit on the recording, but just remember to do your quiz by the latest end of tomorrow, just so you can practice what you've learned this week. And you want to practice it before, so it gets into your head and stays there, type of thing. Okay, let me see if I can factorize this, or I could use the quadratic formula. I think it's going to be y minus 9, y plus 1. And that's going to be greater than 0. And so now I'm going to get my sign table on the number line, and I'm going to have two critical values. What are those critical values going to be? What are my critical values going to be? So I think it's going to be almost Wasima. I agree with you on the 9, but I think there's going to be a -1. And then I also think there's going to be a 9. So the 9 critical values from that bracket and the -1 critical values from that bracket. But when I put them on the number line, they look like that. So when y is -1, this whole expression will be equal to 0. So just to show you that, like -1 plus 1 would give you 0. And 0 times anything is 0. So -1 is a critical value where the expression is equal to 0, and 9 is the other one. Now I need to complete the sign table where I summarize what would the expression be if a number was greater than 9, what would the expression's sign be if I had a number between -1 and 9, and I need to know what is the pattern. If I go from this side, I want you to tell me. So I start here, and then I go here, and I go here. What's the pattern that I get in terms of the behavior? And then let me go to Borma's question. Borma, what's your question?
Hello, sir.
Hey.
Sir, isn't it supposed to be y plus 9 because the 8 is a positive?
Ooh, I think you might be right here. Let's have a look. So if I think you've caught us. So y squared plus y minus 9y minus 9. You have absolutely got this. Guys, I must apologize. I see that there are, I've made a little error in my factorizing. So let's just quickly check. What I should have had is I should have had this, and maybe this is why you were a little bit confused. Y plus 9 and y minus 1. So let's just check this. So y squared minus y plus 9y and then minus 9, which gives me that. Yes, guys. So this is wonderful that we picked that up. And so now my critical values are going to be rather, they're going to be minus 9, and the other critical value is going to be 1. Well done. Well done. Yes. So the moral of the story is sometimes the quadratic formula is more reliable, and watch out for a silly sign mistake sometime. Yes, Talisa. And isn't one of the ironies of life that we often learn more when we make a mistake than when we do it right the first time? So it is something to bear in mind. Let's finish this off now. So this is minus 9. This is 1. What is the pattern of my expression going to be now? Like, what's it going to be here? What's it going to be here? What's it going to be here? Positive, negative, positive. What's the pattern going to be? So if I choose a number bigger than, say, 1, let's say 10, this is positive, this is positive, so that's positive. Then this will be negative, and that will be positive. Now, what is my answer going to be? I want to know where it's greater than 0. It can't be equal to 0, it must be greater. What regions are going to be my answer? I want you guys to put this in the chat, and then we can call it a night for today because we've done really well. And I think the one region is going to be here, and the other region is going to be here. Oh, I see time is short, so let me actually, I'll put the answer in here. So x should be less than minus 9, or x should be greater than 1. And that will be my final answer for today. Give me a thumbs up if you feel like you're understanding. Give me a thumbs down if you're feeling still a bit lost with inequalities. Just want to get a quick feel for the room. And then after we've had our little vote, Lebo, if you could put the link to our quiz in the chat for the students, that would be awesome. Everyone, you definitely want to carry on practicing these skills, but I do hope that these 2 lessons have at least just given you a framework to kind of start working with inequalities. Ayanda's asked, why are they separate? Ayanda, the reason they're separate is the answer is it's this region on this side and this region on this side. And so because they're separate regions, we have separate descriptions of those regions. So there's the one description and there is the other with the or between. All right. Yeah. So don't worry too much. So we've only done about 3 or 4 examples. You're going to have a chance now to do a few more. And then you can practice some more after that. And it was mainly just getting a method that you can use into your head and clear. And now it's up to you to practice a bit more. But actually, inequalities become easy when you've done 10 or 15 of these. All right, are there any final questions? Otherwise, it's been great being with you. Imbali and Zanele, when are they combined? The answers are combined if the answer was, now they're not in this case, but if the answer was the region between -9 and 1, since that's only one region, then we would write that as like, sorry, it shouldn't be X, it should be Y. And I've done that again here, sorry. So this should be a Y. But if you only had one region, you would have a Y like that. Okay. Talisa, it's normally within 24 hours of the main event. Sometimes it's up tonight, but it's definitely up by tomorrow afternoon. Okay. All right. Cheers, everyone. Have a good rest of the week.